This is learning objective outcome 15, interconverting between energy, wavelength, wave number, and frequency. You're going to have to do some reading in a book. I'm not going to give you all the definitions. We'll start off with some symbols and stuff like that. So wavelength is given the symbol lambda. Okay, frequency is given the symbol nu, Greek letter nu. Lambda is another Greek letter up here. And wave number is given V bar. And finally, energy is given the symbol E. Okay, so wavelength is in units of nanometers. Frequency is 1/seconds or per seconds, seconds to the -1, which is equal to 1/seconds. You've got to be careful with this unit. Wave number is equal to 1/wavelength. So the units in this are usually centimeters to the -1. And energy, let me fix that, energy, symbol E, is typically in joules or joules per mole, or kilojoules per mole. So you're going to need this information in front of you. Now, let me erase. Okay, I've written the equations down that we use in here. I kind of got them a little mixed up. So I'm going to separate them with a line. That's energy. This is the speed of light. C is the speed of light, is equal to wavelength times frequency. Energy up here is equal to Planck's constant, H, times the frequency. And wave number down here is equal to 1/the wavelength. And finally, we have another equation for energy. Energy equal Planck's constant, H, times the frequency times Avogadro's number. H is going to be given on the exams at 6.626 times 10 to the -34 joule seconds. Avogadro's number in A, you should know, 6.022 times 10 to the 23rd per mole. Okay, so there's more information. You need to write all this down on here. I'm going to erase some of it, but I'm going to leave the equations on this. We're going to need these right here. So let me erase. Okay, so a typical question you might get is, light has an energy of 300 kilojoules per mole. And they want you to calculate lambda. They'll ask, what is the wavelength? So we're going to have to go through and pick out the equations we know we need to use. So I know I have energy, so I'm going to use either this equation or the top one. And since I have a per mole unit, I know it's going to be this equation, equal H nu in A. Okay, then I got to get from here to wavelength, so I notice that I have frequency up here, and I can calculate frequency here, so I can use this equation as the second one to calculate the wavelength. So I start, this is an algebra outcome, so you have to start and show the algebra. E equal H nu in A. I rearrange the equation. Nu is equal to E divided by H in A. Then I plug in numbers. You have to show the rearranged equation, then plug in numbers. So I have 300 kilojoules per mole divided by 6.626 times 10 to the -34 joule seconds times Avogadro's number, 6.022 times 10 to the 23rd per mole. So now I look at my units, my per moles go, I have per second, and I have kilojoules and joules, so I messed this up, I'm going to put it up here, times 1 kilojoule per 1,000 joules. That's extended out here at the end, okay? So my kilojoules will cancel, and my joules will cancel, and I have per second. So I do this part of the problem. So now I plug into my calculator 300 divided by 6.626 to the negative 34th power divided by 6.022 to the 23rd power times 1,000, and I get a frequency of 7.518 times 10 to the 14 per second. So that's my frequency. Now I'm going to have to erase here in a second, so get that written down on here, and hopefully you put it in a better order. Okay, here's what I have. I have this answer down in the bottom left corner, which I've written. I've got 7.518 times 10 to the 14th per second. I should have 3 sig figs, but I kept an extra one for right now, as I had 3 when I started up here, and all I did was multiplication. Planck's constant and Avogadro's constant should never limit your sig figs. So that's my frequency. Now I want to do the wavelength. So now I'm going to use the second equation. C equals lambda nu. So I rearrange. Notice that is not a V, that's nu. It's a crooked V. So I rearrange my equation, and I get lambda equal C divided by nu. You don't have to tell us how, but you have to show it. Now I plug my numbers in. The speed of light is 3.00 times 10 to the 8th meters per second. We give a better number on there. It's something like 2.99792 times 10 to the 8th meters per second. So this should never really affect your sig figs. So then I divide by the frequency, and I get 7.518 times 10 to the 14th per second. So my per seconds cancel, and I get meters. So I get in this problem 3.00 times 10 to the 8th divided by 7.51 times 10 to the 14th, and I get 3.99 times 10 to the minus 7th meters. One thing I didn't show here, frequently we ask this in nanometers. You can either do it separately, or you can tack it in your conversion in here in your problem. That's it. So typically what you're going to do is I might give you anything. I might give you frequency and ask for wavelength. I might give you wave number and ask for energy. I might give you frequency and ask for energy. I could give you energy and ask for wave number. So I'm going to ask a lot of different ways. You really need to have these equations in front of you.